If aliens ever tried to contact Earth, the most likely first message would not be a spaceship. It would be a radio signal. Radio waves travel enormous distances, pass through space easily, and do not require moving any physical object across the galaxy. That makes them the cheapest and most practical way for one civilization to announce that it exists. But the universe already produces natural radio noise. Stars, planets, gas clouds, and dead objects all make signals of their own. So an alien message would need to stand out. Scientists think the clearest version would be a narrow band signal, a signal compressed into a very tiny slice of frequency that nature almost never produces by accident. It might also repeat in a mathematical pattern, like prime numbers, pulses, or a structured code designed to look artificial. That is why radio telescopes still listen to the sky, because the first proof of alien intelligence may not arrive as a voice. It may arrive as a pattern too perfect to be natural. But radio is only the beginning. The next method would be faster, brighter, and much harder to ignore. A laser message would be the cosmic version of flashing a flashlight across the galaxy. Unlike radio waves, laser light can be focused into a narrow beam. That means an advanced civilization could send an extremely bright pulse toward one specific star without wasting energy in every direction. To a telescope on Earth, the pulse might appear for only a tiny fraction of a second, but during that moment it could shine brighter than the alien civilization's own star. The challenge is precision. The sender would need to know exactly where Earth will be when the light arrives, possibly years or centuries later. A natural star flickers randomly. An artificial laser could repeat in perfect intervals or carry information through carefully timed flashes. We may not hear the first alien message. We may simply see one impossible blink in the dark. But light still requires the sender to aim directly at us. The next method could hide a message inside mathematics itself. An alien message might not begin with words, pictures, or sounds. It might begin with numbers. Mathematics should work the same everywhere in the universe. 2 plus 2 does not change on another planet. Prime numbers remain prime. The relationship between circles, angles, and patterns should be recognizable to any civilization capable of building a transmitter. That makes mathematics one of the safest ways to prove a signal is artificial. The message could arrive as a sequence of pulses: 2, 3, 5, 7, 11. Nature can create repeating rhythms, but a long sequence of prime numbers would be difficult to explain as an accident. Once attention was captured, the pattern could become more complex. Binary code, geometric ratios, instructions for building an image. It would not tell us who sent it, but it would tell us something had chosen to be understood. And the next clue may not come as a message at all. It may be hidden inside the atmosphere of another world. Aliens might contact Earth without sending any message at all. Their planet's atmosphere could reveal them. When an exoplanet passes in front of its star, some starlight filters through the planet's atmosphere. By studying that light, astronomers can search for gases that should not exist together naturally. Oxygen alone would not prove intelligence, neither would methane. But unusual industrial chemicals, artificial pollutants, or gases that require constant technological production could be different. They would act like smoke rising from a distant city. The civilization might not even know we were watching. We would not hear a greeting or decode a message. We would simply discover that another world had changed its atmosphere in a way nature could not easily explain. But pollution would only prove that technology existed. The next clue could reveal what that civilization had built around its own star. An advanced civilization might contact us by changing the light of its own star. Every time a planet passes in front of a star, the star dims by a small, regular amount. But a gigantic artificial structure could create a stranger pattern, uneven dips, unusual timing, or a shadow far larger than any normal planet. One possibility is a Dyson swarm, millions of orbiting collectors built to capture a star's energy. From Earth, We might never see the machines directly. We would only see the star behaving wrong. Its brightness could fall in complex patterns. Extra heat might appear in infrared light. The system could look less like a natural solar system and more like a machine under construction. The civilization would not need to send us a message. Its engineering would be the message. But a megastructure could still be thousands of light years away. The next sign might be visible on the dark side of a nearby world. The first visible sign of an alien civilization might appear when its planet turns away from its star. On Earth, the night side glows with cities, highways, and artificial lights. A distant civilization could produce the same effect. Powerful telescopes might detect a faint glow that does not match reflected starlight, volcanic activity, or lightning. The pattern would matter. Natural light is scattered and temporary. Artificial lights could form stable clusters, networks, or coast-like shapes that return every time the planet rotates. Detecting them would be incredibly difficult. The planet would be tiny, dim, and buried in the glare of its star. But a civilization far more advanced than ours might illuminate entire continents, or use wavelengths chosen specifically to be noticed. We would not hear a message. We would see proof that someone else had built a world that stayed bright after sunset. But light can be hidden by distance and dust. The next method could pass through planets almost untouched. An alien civilization could send a message using particles that pass through almost everything. Neutrinos barely interact with matter. Trillions of them move through your body every second without leaving a trace. They can travel through planets, stars, dust clouds, and entire galaxies with almost no resistance. That makes them almost impossible to block. A civilization could encode information by firing neutrinos in carefully timed bursts. The message could pass straight through Earth and be detected on the opposite side of the planet. The problem is energy. Producing a strong, controlled neutrino beam would require technology far beyond ours. Detecting it would also be extremely difficult because most neutrinos pass through every detector without reacting. But that difficulty would also make the signal convincing. Nature produces neutrinos. Nature does not usually arrange them into deliberate patterns. And the next method would not send information through space. It would send the messenger itself. Instead of sending a signal, an alien civilization could send a machine. An interstellar probe would travel slowly compared with light, but it could carry far more information. It might contain images, mathematics, biological data, or even an artificial intelligence capable of speaking for its creators. The probe would not need to cross the galaxy in one journey. It could travel to a nearby star, use local material to build copies of itself, and send those copies farther. Over millions of years, one machine could become an expanding network spread across the galaxy. We might discover such a probe near an asteroid, hidden behind the moon, or quietly watching Earth from a stable orbit. The strangest part is that it might already be here and look nothing like a spaceship. The next possibility is even more unsettling, because the visitors may have left something behind long before humans learned to look. An alien civilization might not contact humanity directly. It may have left something behind. A small artifact could be hidden on the moon, buried inside an asteroid, or placed at a stable point in space where it could survive for millions of years. It might be a transmitter, a recorder, a map, or a machine waiting for a civilization advanced enough to discover it. Unlike a radio signal, an artifact would not fade with distance. It could remain silent until someone approached, touched it, or activated the right sequence. The hardest part would be recognizing it. An alien device may not look like a machine. It could resemble a rock, a crystal, or a simple geometric object. The message would not be, "We are coming." It would be, "We were here." And the final method is the one humanity imagines most. They arrive themselves. The clearest possible contact would be an alien craft entering the solar system. Unlike a radio signal, there would be no debate over whether it was natural. A controlled object slowing down, changing direction, and approaching Earth would immediately prove that intelligence exists beyond our planet. But direct arrival would also be the most unsettling form of contact. We would not know why they came, how long they had been watching, or whether the craft carried explorers, machines, or something we could not recognize as life. Communication might be impossible at first. Their language, senses, and way of thinking could be completely different from ours. Humanity would finally have an answer to one of its oldest questions. We are not alone. But in that same moment, a new question would become far more important. What do they want? If you made it this far, comment "contact" so I know you received the message.